Okay, so today we are going to move into vector and parametric equations, and these are going to be used to model movement. So we're going to do a lot of physics-based real-world applications beginning tomorrow. As I said before, it would be most helpful if you were actually taking a physics class, you know, at the same time that you're doing these, but I guess it is what it is. Why will my screen not move over? Give me one moment here to try to get this thing working. All right, hopefully that's working. We'll see. Okay, so some background on vector and parametric equations. So back over to your notebook, and you want to make a heading that says section 8.6. And this is going to be vector and parametric equations. So vector and parametric equations. And you got to write a little bit first before we kind of get into these. So vector and parametric equations. So your real world applications with this. So I want you to copy down the vector equations. Actually, I'm going to abbreviate that. So vector and parametric equations are used to model movement. So vector and parametric equations are used to model movements. So used to model movements. So these are going to be instead of just typical lines in your coordinate plane. So vector and parametric equations. You're going to make these a little bit different. So parametric equations can be written if. So parametric equations can be written. I just want to be careful with notation today, but these are not bad at all. Can be written if you know the coordinates of a point. If you know the coordinates of a point in the direction of a vector. Coordinates of a point and the direction of a vector. Again, these formulas are not going to be anything that you have to commit to memory. They are on your formula sheet for your test, your quiz, your final. All right, so the first one we're going to put into your notebook is called a vector equation, and that is right on the top of your formula sheet. So it's called a vector equation. It also means the vector form of a line. So your vector equation directly off your formula sheet, again, you don't need to memorize this, is going to be x and then minus x1, the little subscript, and then y minus y1. And this is equal to a lowercase t multiplied. This is where you would place your vector in here next, by a sub 1, comma a sub 2. Okay. And again, we're talking about movement here, so that's why you're going to have t, which is going to stand for time, as your independent variable. All right, so this is going to be for the line. I'm going to say this is for the line through the ordered pair xy, and it's always going to be parallel. Going to be parallel to vector A, where that is denoted as a sub 1, a sub 2. And then t, as I just said, is your independent variable or your parameter. So t stands for your independent variable or parameter, however you want to word that. So independent variable slash parameter. Okay. Now you also have on your formula sheet, if you notice, this is the second box. Do you guys see where it says parametric equations of a line? Those we're going to work with as well. But what I'm going to start is just kind of give you the precursor step to what's on your formula sheet. So then make another category here that says parametric equations. And you're going to be asked to find both of these today, but just based on a point and the direction of a vector. So your parametric equations, how these are going to be found is you're going to have x minus x1 equal to, and then what you're going to do here is you want to just think about like distributing. You're going to do t times a sub 1. So t multiplied by a sub 1. And then you're going to manipulate these into what it looks like on your formula sheet. And then my other one, same deal. I'm going to take this, whatever that's equivalent to. And that is equal to, again, I'm going to distribute. So it would be t multiplied by a sub 2. So t multiplied by a sub 2. And just be careful when you see the t's, that you don't confuse it for a plus sign to try to make it like a lowercase t or something to distinguish that. These are what we call the parametric equations. And again, these are going to pass through your point and be parallel to your vector. So they're going to pass through some point and be parallel to your vector. Parallel to your vector. Okay, so now we're going to give you your first example. We're going to start with finding a vector equation and move into a parametric equation. So you'll have to kind of stop once you plug into your vector portion. All right, so I'm going to flip this. I'm going to say number 1. They're not wordy. So part A is I want you to write a vector equation. So I'm going to write a vector equation for a line through line passing through, and I need to give you an ordered pair. So I want to go 1, 4 is your ordered pair, and parallel to vector A. You can use the parallel symbol if you'd like. Parallel to vector A, which is going to be -1, 2. Okay, very, very easy. You're going to look at your formula sheet just so that you are comfortable referring back to that. And the vector form of the line is x minus x1, comma, y minus y1 equal to t multiplied by a sub 1, a sub 2. And literally all you do is you're going to plug in those 4 values and you are going to stop. So I am going to plug in, I'm going to underline these. I'm going to plug in, actually I'll do arrows right here. I'm going to plug in right here. I'm going to plug in right here and right here. All right, so that's it. So we are going to go here, x minus 1, and then y minus 4, and that is equal to t multiplied by -1 and 2. That's it. That's where you have to stop. How's that pretty easy? Okay, so now moving into part B. What I want you to do is take these into parametric equations. So I'm going to say now, write the parametric equations. Parametric equations. So again, this is the second box on your formula sheet. So what I'm going to do is I'm going to take x minus x1 and set it equal to t multiplied by a sub 1. So here's the formula per se, and then I'm going to go up to my example and just kind of like draw arrows instead in case you want it like that. So I go x minus x1 is equal to t multiplied by a sub 1. So what does that mean? It means I'm going to underline this in orange. I take this part right here, and set it equal to this one multiplied by that one. So I'm going to go x minus 1 equal to -1 times t. And then what I do is just solve for x equals. So if I solve for x equals, I just need to shift my 1 over. So I go +1 +1. So my first parametric equation is equivalent to -t + 1. Pretty straightforward. There's a lot of remembering where things go. Now I'm going to do something similar for my second. So I'm going to go y minus y1 is equivalent to t multiplied by a sub 2. All right, so I'm going to distribute that one too. I'm going to do that one in blue here. So I take this right here equal to the t multiplied by the 2. If that works. So y minus 4 equal to 2 times t, and then solve for y equals. So you're going to add your 4, and you're set. So I have y is equal to 2t plus 4. And again, these are going to model movements. That is why you have a t in them. So t is your independent variable. Okay, how's that question? Pretty good? All right, let me give you another. So I'm going to just make this go, it's essentially backwards, but not further. So number 2, your question's just going to jump and say finds the parametric equations. We're going to go find parametric equations for line parallel. I want to go for line parallel to vector v, no matter what letters, and that is going to be 3, -5. And I'm going to give you an ordered pair. And ordered pair is going to go through 4, 3. Okay. So what you're going to notice is that this does not ask you for the vector equation, but it doesn't matter. You have to start there anyways. So first I find the vector equation, then I work with it one more step further to find the parametric. So I'm going to start right off my formula sheet again. And you're going to begin with the vector equation. So your vector equation is x minus x1, y minus y1 equal to t multiplied by a sub 1, a sub 2. You're going to set those in. So we have, and you want to be careful, because what goes into the first set of parentheses? The 3, -5, or the 4, 3? Careful. The point. So that goes here. That goes there. So I reverse the order. So be careful. So you're going to go x minus 4. You're going to go y minus 3. And that is equivalent to t multiplied by your vector 3, -5. So that is the vector equation, but I need you to go further. So now you have to find your parametric. So to do the parametric, you're going to do the same thing we did in that last example. Essentially, like you're distributing. So your formula is you're going to take x minus x1 equal to t multiplied by a sub 1. And you're going to go y minus y1 equal to t multiplied by a sub 2. And sub them in. So x minus x1 is x minus 4. And this is equal to t multiplied by 3, which is just 3t. Bless you. And then when you solve for these, you're looking to get x by itself. So I would do +4 +4 and done. So x is equal to 3t plus 4. Over here, I'm going to go y minus 3 is equivalent to -5 times t. +3 + 3, and you're good. So y is equal to -5t plus 3. Okay. How are those, okay? Again, when you're asked for parametric, you're going to have to first start with that vector equation. your answers to continue that. All right, so next type. This one's a little bit different. The next thing I'm going to ask you to do is write an equation in slope-intercept form. You're going to write an equation in slope-intercept form. Whose parametric equations are I'm going to go down so I have a little bit more space. So I want to give you x is equal to t minus 2. And then your second one, I'm going to go y is equal to negative 3t and then plus 4. Okay, so this is essentially where your last problem left off. And now you have to take these and write them into slope-intercept form instead. So when you're done, y equals mx plus b. So what I need to begin by doing is I need to solve these both for t so that I can set them equal to each other so that the t is essentially gone. So I'm going to start and go over here. So I'm going to solve for t to these. Okay. So I would do on this one plus 2 plus 2. And my first is going to be t is equivalent to x plus 2. Over to the other side as well, I'm going to go minus 4 minus 4. I would have y minus 4 equivalent to negative 3t. Get the t by itself. So I'm going to divide this by negative 3. And I'm actually going to just leave it like that for the time being. So this equation is t equal to y minus 4 over negative 3. And my last step is to set those equal to each other because they are both set equal to t currently. And I'll do this. So this is like part A, and then part B. I'm going to say set equal to each other. I'm going to set these equal to each other. So I'm going to take the x plus 2 equal to the y minus 4 over negative 3. And then you're going to cross those by and manipulate your equation of y equals. So I'm going to distribute this. So I have negative 3 times x, so I have negative 3x minus 6 is equal to y minus 4. And last, I'm going to take that 4 added over, so plus 4 plus 4. Resulting in my final answer in slope-intercept form of negative 3x minus 2. Okay, and that is that answer. Okay. Are we good on procedure to get slope-intercept? Okay. So just 2 things that you have to do there. All right, and then one last question. So your last question here, number 4, and you can kind of start in practice, is I want you to write y equals negative 2x plus 1 in parametric form. So this is really easy. It doesn't involve any work. What you're going to do to take this to parametric is you're going to state that x is equal to t, and then you're going to replace it. So these are both part of your answer. So my answer becomes y is equal to negative 2t plus 1. Again, you are just replacing your x to model motion instead. It's just not, a typical line on a coordinate. So that's it. All you do is you substitute your x value for a t instead. How do we feel with the parametrics, okay? So for homework, you have 2 sections of problems. So you have page 524, 13 to 21 odds to do, and then 25, 27, 29, and 31. Tomorrow, we're going to start working with the real world examples to model your motion. So that is your worksheet A in your packet. And then your quiz on Monday only covers 8.5 and 8.6. Okay, so you won't have any of those word problems that we do tomorrow just yet. Okay, you got time to get those started. Let me know if you had any quiz questions as well.